All right, folks, we are a bit late. So without further ado, please welcome Rohan and Jason, who will present their work titled PraxiPaaS, AI-based telemetry analysis and root cause inference with PraxiPaaS. Please take it away.
All right, now it's showing up. Okay. All right. So morning, everybody. My name is Jason. I'm Rohan, and today we're going to present PraxiPaaS. So to start off with some more background, like high-level overview, our system is mainly on top of platform as a service clusters, and so essentially, platform as a service has recently gained a lot of popularity, mainly for due to the fact that developers don't have to worry about more of like the complexities of maintaining their systems. They can easily just sort of a pay-as-you-go model where you can easily scale up or scale down your application as you go, and so it's really easy for developers to kind of just write the applications and then easily publish it onto the cloud. But however, some of like the biggest biggest drawbacks to increased complexity as some of their applications scale up is that it adds more potential for anomalies to occur on their system. And so some of these applications can have multiple different third-party projects on top of their application. It's hard to track exactly where everything's coming from. And so it's also harder for the system administrators to easily address different anomalies that might occur on this cluster. So our system, we propose PraxiPaaS, which is a more of a tool to put on top of a cluster where when an anomaly occurs or there's a problem on a container, on the container level, we want to correlate that anomaly with some sort of recent change to that container. In our case, we're more of inspecting the containers to look at package installations. And so hopefully we want to kind of correlate the package installations with the anomalies in order to help admins diagnose issues faster. And we also want to automatically infer. And so yeah, so I guess more of the background for our project comes from Tritium and PraxiPaaS, which okay. We'll kind of talk about.
Yeah, so Tritium is basically the inspiration for Praxium. This is also previous work done in Professor Koskin's Peak Labs. The basic idea behind Tritium is that we want to detect an anomaly within a cluster and then correlate that anomaly with the new microservice rollout. And then when this occurs, we also want to do some rollback hypothesis testing just in order to mitigate that anomaly. The basic goal behind this is to help admins automatically mitigate those cluster anomalies that are caused by new service rollouts. So as you can see from this diagram here, there's a couple parts. I know it's a little bit hard to see, but on the left, we have the cluster where we collect telemetry data, event data, and trace data. This is all fed into a database, and then metric data is checked continuously for basically any anomalies. When an anomaly occurs, that's passed to a root cause analysis with the event data and trace data. And then the root cause analysis component basically finds whether there's a correlation between that microservice rollout and some anomaly. And then root cause testing is done after that to see whether that hypothesis is correct. And then the second background piece is PraxiPaaS. So this is work that Jason and I worked on in the previous year. PraxiPaaS built a package installation log for each container within a platform as a service medium. The goal behind this is to basically, instead of using a rule-based methodology for finding which packages are within a platform as a service medium, we want to use a machine learning approach in order to find vulnerable, outdated, or potentially malicious packages. And then again, this also helps cluster admin to find root causes by leveraging package information. So the way PraxiPaaS works is by inspecting file system changes within the platform as a service medium. It tokenizes those changes and then use those tokenized changes to predict which packages are found. And then this is an example of a log. So we have the image name for each container within that platform, a package list for that container, and then a timestamp for when that installation log is last updated for.
So here's kind of a high level overview of our proposed pipeline for Praxium. To kind of take you guys through sort of our pipeline, it starts off with our microservice, our container. We have Prometheus and PraxiPaaS on top of it to monitor, and it's sort of like the observability for the container. And Prometheus is constantly collecting telemetry data from the containers, and then PraxiPaaS is introspecting the containers to look for the packages that are installed, as well as logging the timestamp information and the packages. And then we have our anomaly detection unit, which is monitoring the telemetry data. And if it detects an anomaly, it will retrieve the installation logs from PraxiPaaS, as well as retrieve kind of the key metrics of the anomalous data, and it will deliver it to our root cause analysis system, which we'll talk about later on, and that will give us a diagnosis or a sort of overview report for the system administrators to kind of more so isolate and diagnose the problem. And so here's a more timeline approach or overview of our system. So here you can see our containers initialized at time 0, and then we have our anomaly detection, which currently we've used statistical augmented Dickey-Fuller tests to check if there's an anomaly, and then we have PraxiPaaS as well. It's scheduled to kind of observe the containers and check for packages that are installed. And then here at the time where we install NumPy, we do another statistical test to check for anomalies, and we constantly have that on a continuous structured schedule. And then at the point where we install a faulty package, our anomaly detection unit will detect anomalous metrics from our Prometheus, and that will trigger up another PraxiPaaS pipeline, and in which it will get the most recent changes from the container, and it will deliver all those metrics to our causal impact.
Sorry, quick question.
Yeah.
I want to understand, how do you do anomaly detection? I mean, what kind of anomalies you're fishing for? Things that completely break the entire thing, or because I can imagine there are faulty packages where they have faults that only trigger on some weird branch of some weird function and nobody uses, right?
So we have this slide kind of more detailing
talk
outline
about
of it, but so our first step was more of a feature extraction. We use the principal component analysis just to sort of extract the most relevant features that we want to observe for our anomaly detection. So in our initial approach, that Tritium used actually, which is the model we based off of, they used this statistical testing, in which they kind of test the target metrics that we pulled from the PCA, and it's testing a null hypothesis to check if there's whether like a unit root is present in the time series data. But then currently we've explored different approaches to anomaly detection, such as using a more machine learning approach, in which in our lab we also have a framework called Prodigy, which is a variational autoencoder based anomaly detection method. And so we saw like in our initial approach, it was more of sort of a simpler approach that we wanted to mimic same properties that Tritium used.
So wait, so, hold on, I want to understand, what kind of anomaly? Are we talking about crashes or degradation of performance?
Yeah,
Yeah, right
so-
now, we're mostly targeting like latency and throughput. So if there's a
Latency?
yeah.
Okay.
So the idea is for now, we'll have like the admin kind of designate one target metric, and then it'll keep track of that as well.
And that to me means that you have a reference worker in which you practice metric, that it's kind of stable throughout.
Yeah.
Ah, okay. You know, okay, so you know the container, you know the workload. But if the workload is always the same and the container is always the same, why would anybody want to install different packages if you just keep running the same workload?
Maybe just because the packages are outdated, we're thinking about push out a new rollout. There's
This goes against the. It's fine, it's interesting, okay, I see, so there's a little question over there.
It's a time series because you have the checkpoints. That way it's considered a time series.
When we collect this,
Yeah, the metrics are
Yeah.
time series.
yeah, from EPS metric data, so it's.
So as the container is being built, like as fact
Well,
that they're getting
it's already
installed.
deployed onto the cloud and it's constantly monitored.
As the microservice is involved.
Yeah.
Right, okay.
And so to touch more based on our root cause analysis, we use the Google causal impact, the Google causal impact framework. This is also another approach that Tritium used. And so essentially it creates a counterfactual model in which it will predict what would have happened in the absence of some sort of intervention, such as a new rollout or package installation. And then it also has a flexible time series decomposition, which will break down the time series data into the trend, seasonality, and noise to help understand the patterns and changes in the data. And it also has an uncertainty quantification.
Quick question on this, because you said that it does this counterfactual thing in predicting stuff. Are you actually trying this, or are they just predicting things speculatively?
There.
Are they actually trying these counterfactuals? Are they instantiated in lab, or are they just speculatively predicting?
So here we have like an example of how it's working. So we have our data X, and then we have a dependence Y where it's doing taking like a function of X, which is 2 times X in addition of noise. And so let's say we added like some sort of anomaly, or we added like a value of 8 as like an impact into the data. The causal impact algorithm will sort of take the data before our intervention timestamp, and it will predict some new counterfactual values based off of the historical data before the intervention.
Can you show that plot again?
Yeah, so here we have some data X, some random generated time series data.
But actually, this is your real metric. I mean, right now it's random.
Yeah,
generated,
yeah,
but you
yeah.
mean this is actually
Yeah.
your metric.
Yeah, so
Okay.
this is the true data. And so how the causal impact.
So okay, that's your real data, and then you have so that's the one. Okay, and then Y is what?
Oh, so Y is a function of X, so it's
Okay,
dependent on
and then you're showing just some other data which is independent, which is
yes.
Okay.
And so how like the causal impact algorithm is, it will predict based off the patterns and trends of the data before the intervention. And it will compare the predicted values with the actual values. And that's how it's kind of measuring its level of causal effect into our data. And so we're trying to leverage this functionality to check between the different package installation timestamps and checking which one has the most causal effect to this anomalous data.
Oh, okay. So we wanted to kind of explain some of our experimental design choices. So last semester, at the end of the semester, we ended with a demo. This was basically a sample deployment, which would comprise of 3 healthy containers. which were just benign, installed some random, healthy packages, and then one anomalous container. We chose to spike the CPU utilization by basically just running some function that does some multiplication across multiple threads. And we did this for 10 minutes. We also had granularity on how much of the CPU is spiked. So we chose, I think, 60% spikage. I think it just hogged 60% of the threads, if I remember correctly. And then the goal of this was just a proof of concept of the system working in action. And it basically just demonstrates that there's successful container introspection. It could detect the anomalous behavior, and it could also provide a detailed report for the system administrators. Let's see. Okay, let's see what's gonna. Okay, so it's pretty small, so I'm gonna narrate it. So the basic idea, so this is our cluster within NERC, and you see we have some anomalous container here, or a pod that contains a single anomalous container. So the setting for this demo is after we ran PraxiPaaS at least once. So in this MongoDB database, which is what we're using temporarily, you'll see that we have each named container. So this container is called anomaly CPU. Other ones are called introspect. And we have these packages that are found using PraxiPaaS. So this one had PyYAML and TZ data. This one had a couple more, and so on and so forth. And now we can run the Praxium system. So this time we triggered it manually, but when we deploy it to an actual system, the goal is to run this on some sort of scheduling system. The way that it works is, as I mentioned before, we find the containers, we check for an anomaly. So this already found the anomaly because it's a pretty small system. And then we run PraxiPaaS one more time just to make sure we collected all the proper packages. This is the pipeline of PraxiPaaS working. You can see we're collecting the same packages again. And then at this point, we run the causal impact based off the anomaly detection. We found here that it's kind of hard to see, but the container anomaly CPU made an impact, which means that the causal impact found that anomalous package was doing something in that specific container. And then the output of this system is the results being that container and then the probable packages that could be the cause of that anomaly. Okay, so moving into
I have a question.
Yeah.
Would this system only work if the change is recent? Like if I updated the package with the anomalous over the last hour? Or if I updated like 5 hours ago or yesterday, can it still catch the correlation between the anomaly and?
So I think that depends on how much time series and metric and package data we keep in the past. So depending on how granular the admin would want it, they could keep that in the past. And theoretically, it should be able to find that correlation regardless, because it just looks at when the packages are installed, since those are timestamped, and then when the actual anomaly occurs.
How can you tell if it's, so if you get an anomaly, how do you tell if it's a false anomaly detection or a true one?
So I guess
you're using a machine learning model.
Yeah, so the idea is that this is kind of just a diagnosis. It's not necessarily the cause of the anomaly. So this is just to help admin in case that it is the case that a package is the cause.
What I mean, what if it's not an anomaly and your machine learning model is saying it's an anomaly? How do you know?
Then I guess that's just a problem with the system. I mean, we plan to test it in order to make it a little bit more robust.
Well, you're saying it could be somebody has optimized the package and all of a sudden it runs much better.
And
Oh, yeah. So an anomaly in this case, yeah, that's a good point. I guess we would limit the anomalies to malicious or like bad anomalies, like you could say like increases in frequency.
In general, like there's no distinction, there's no golden data set for this. So it's detecting the anomaly. It's up to the administrator at this point to say that, an anomaly was detected and the system thinks that it's due to this package installation. That's the info they get. But it doesn't tell whether it was a true anomaly or a false anomaly. That would be a kind of like an orthogonal problem to how to label them and.
yeah, figure out whether the anomaly actually means an anomaly to me, right? Just kind of.
Yeah. So I think when we say anomaly in terms of Praxium, it just means that there's been some change in metric data. and we want to reflect like what made that change.
Okay.
Okay, so,
There's another question.
oh yeah,
This might be a dumb question, but how do you know that, say I have two packages and I update one of them, but the actual problem is that, like, let's say I update package A, but package A depends on package B, and that's what's actually causing most of my system issues as a dependency?
but you said you only updated package A.
A, yeah,
So package, so wait.
like imagine you're in a rolling update system, right? And you can just update a couple packages, and you know that those packages by themselves work fine.
Yeah.
It's only when they interact with, let's say, an older package.
Mhm.
What would you flag as the anomaly then? The newer package that you updated, or that the older packages are out of date?
The way our system works right now, it'll just flag the entire container and then return a list of those packages. So in theory, in that case, it would just return again,
Oh, okay,
like
so it's
all the
like all or
packages,
nothing.
yeah. Mhm.
Thing. Okay, gotcha.
But that is something that we're thinking about for the future, like how can we make it more? Which I'll talk about in the future plan section. Okay, any other
Partnership.
questions before I? Okay, so the experimental plan starts with testing the robustness of the system. Our idea is that we want to expand our demo into multiple different target metrics. So we're gonna do this by spiking latency, as I already did, memory, HTTP requests, and disk IO, in similar fashions to the CPU utilization. And then again, we're just gonna build a dummy Python package that will introduce a delay. We'll also, so then we'll inject the anomaly into the target metric. We plan to do this so that the anomaly also ranges from like on its magnitude. So there could be weaker anomalies and stronger anomalies, just so we can capture how well our system works against anomalies that aren't as strong. And then we hope to capture the accuracy of the results over some set of samples. And that would be outcomes of whether the anomaly is detected and whether the causal impact correlated the correct container and package installation log to that anomaly. And then the second method that we're looking to do this semester is testing the anomaly detection consistency and sensitivity. So this means that we're going to be injecting several anomalies in a short time frame, and then we plan to observe and record which anomalies are detected. And then the hope for this is we can use this as kind of a gauge of how well Prodigy works normally, and then adjust it to make it better suited for catching like metric anomalies within our system. So just as a summary, the last semester we created a functional proof of concept system using PraxiPaaS, causal impact, and the statistical anomaly detection unit. And then this concluded with a working demo. This semester we're replacing this statistical anomaly detection with Prodigy for unsupervised multivariate detection. And then we're also going to be implementing several experiments to test robustness, sensitivity, and the consistency of this system. Lastly, some potential additions. The first thing is we want to improve the flexibility. So we chose PraxiPaaS as a good way to kind of correlate anomalies with some sort of logs. But in theory, this doesn't need to be package installation logs. And it definitely doesn't need to be Python package installation logs. So this could be returning to the microservice rollouts of Tritium or doing something else. But our hope is to make it so that PraxiPaaS is more of like a plug and play type of system where we can change that out for different types of like log collection systems.
Correct me if I'm wrong, but on these systems, don't you have a staging file system like BTRFS, something like that, that constructs a tree of changes over time? You familiar with that stuff? It's not in the domain, but you know BTRFS?
Yeah.
It's the one that creates a tree of delta changes, right? So you could hook into that and say, okay, for any branching point in this file system, has there been any?
Oh, I see what you mean.
Okay.
So I thought it's not specific to NERC. I see. So it's just basically tracking file system changes.
Yeah, and create like a tree of changes,
Yeah.
sort of from where it started, from any change kind of create a split in that tree. you could potentially use that as sort of a checkpointing to figure out which change creates the spike or the change in your
That
bank.
makes sense.
There are many options. I mean, one could also correlate this with some sort of a tracing system that
Right.
looks into specific delays of services. So PraxiPaaS was something we were developing, so that was a natural connection, but
And we
like
had
this is a good
previous-
idea though, like.
Yeah, that's a good idea. Okay, so the next thing we wanted to add was versioning. PraxiPaaS already has been proven effective for package version differentiation. And right now that isn't supported within our current system, but that should be a pretty simple change if time permits. It basically, it'll give us more granularity on finding whether packages are updated or not. And then lastly, we wanted to increase the granularity, as mentioned before, by finding which containers, which packages within the containers are specifically anomalous. We're not exactly 100% sure on how to do this yet. We're still kind of thinking through that problem. But obviously the goal would be to have like a direct mapping of the anomaly to the package itself, or a group of packages that could meet the problem.
But you have that information already, right? Because it's like PraxiPaaS already has that info on what got updated. So you're not creating that output out of Praxium yet, but the information is there in PraxiPaaS.
Yeah, the problem is like the question that was asked, like it's harder to narrow it down to a specific package because that package could be informed by other packages. So on.
So I guess here you have the to generalize the problem, you have the problem of defining what is for you a transaction, right? Meaning a transaction that changes the state of your system. In this case, you define as a transaction the installation of a package.
Right.
But that transaction could be maybe the creation of a temporary piece of output file that then impacts how the system works
Sure.
later. So I guess you can generalize and say, try to identify what was the root transaction that introduced the anomaly, and then try to narrow down why, or if it's a byproduct of processing, or these are all stateless things. Are these containers all stateless?
I'm gonna look at.
They're all stateless? Okay, so you cannot persist anything on them.
Yeah, and also like when PraxiPaaS runs, it is running only on the installation, like at the time container is pushed as an image. So it takes the image and takes the delta of the image that, okay, these are the new packages installed and now the container will run. So we have the delta that, okay, these packages were changed. And we can point that, okay, these packages are responsible for whatever degradation is
But
there.
I thought that's the delta, but he was asking if the containers are stateless.
Yeah, they are stateless, they are not maintained.
Every time you invoke a microservice, the whole thing is started from scratch, like fresh, alright?
No, no,
Not necessarily.
but that is functionless. So stateless is like they are not maintaining any state in themselves. They are not maintaining some database inherently.
Right, that's what I mean. So basically, I put it this way, performance cannot degrade as a side effect of what you did in the past, right?
What do you mean?
So let's
Yeah,
say.
yes.
Let's say, for example, that a package creates a cache, right? And then every time you run a function, that cache is looked up into. If that cache keeps growing, then the lookup time increases, and then the millionth time you run the same function, you hit a snag because now your latency explodes.
Yeah,
That cannot happen.
Yeah, we are not creating any cache.
That's simpler, yeah. You can track where the changes are to the container image.
True, yeah.
I have a question that relates to the title of your presentation. The title promised us root cause analysis. It looks to me that all you're doing is running correlation between package installation and changes in metrics.
Yeah, so
Where's the causality here? Root cause implies causality.
yeah, so the root cause analysis, we're specifically referring to using Google causal impact within it, in order to, I guess, kind of,
But that's not what you're doing, right? The only thing you can tell is after I installed those many packages, whatever is between your intervals of checking your package installation, things went bad.
sure, but I think we're trying to find, so the root cause in this case would be that change across several different changes that we could have made.
Yeah, root cause of.
So you assume there can be no other reason than a package installation that breaks your system, changes metrics.
No other reason.
Yes.
that a package installation, well, I mean, in this case, so the idea is that we just want to give the admin like something to work with, a diagnosis of the problem that it could be these packages. It's just a tool to help the admin
But
when
that's not
they're,
the root cause. The root cause is not, it could be one of these things. I can always tell you, your machine is broken. It could be any of the things that's in your machine.
sure,
Right?
yeah,
What you're doing is, your machine is broken. Here are several pieces and we believe that something of one of those pieces is at fault.
yeah, that is what we're doing.
But you're not saying that one of those pieces is at fault. You say, we believe that
Yeah,
one of
that's
those
true.
pieces is at
Yeah.
fault. That's not what a root cause analysis is.
Okay,
It's root causing, I mean, it's providing,
Pointers to that,
A direction.
to fault.
Yeah.
exactly. So
Narrowing it down.
yeah.
normally you only have the telemetry to look at. This is saying that if, whatever happened in the disk IO, go look at these packages.
Right.
So it's giving you something to look at.
Not single email of developers, please.
I got another question. So in your proposed future work, you were talking about two things that you're planning on doing, like flexibility, yada, yada, yada. You experimented with one type of anomaly, hogging the CPU for 10 minutes at 60%, and
Yeah.
maybe tuning some of those knobs. Hogging 60% of your CPUs for 10 minutes is a blast of a signal, right? So my question is, what are the anomalies that people encounter in reality? And how do those relate to this huge signal of 60% of all your resources are just wasted?
Sure, okay, so the first thing is, we're not 100% sure of any real world examples yet, but that is something that we're gonna be exploring this semester. Like what the average CPU spike looks like or something like that, or at least something that's realistic. The second part is in our experimental plan, what we're gonna be doing when we're injecting the anomaly is testing out several different thresholds for how strong that anomaly is, and that should hopefully cover the basis.
So I think,
Do you know the drift in the metrics in regular application or the regular use of these containers? Like a real system, a real microservice that does not consist of jokingly one installation of a container, it's a real deployment. People make changes,
Right.
metrics change,
Mhm.
right? If you're too sensitive, you flag these as anomalies. We have at least a sense of what the expected value of change is.
Not really.
I mean, no, but I think basically this is basically broadening, but this question is important. It's a very difficult problem, right? So nobody has, here's a golden list of anomalies data set out there. But there are some studies, especially from companies, typically they are dated. They are not showing what's, currently popularly wrong in their systems. But at least, some of these could be connected to what's more relevant in real time. Like I said, I'm not aware of like a nice golden data set, like here is a bunch of telemetries with anomalies labeled. It would be great. There isn't, but I think it's good to still study that, like what people are talking about in the cloud space.
Yeah, I would, if I were you, I would start with something similar where somebody throws a Bitcoin miner in the packages, right? That should simulate this kind of spikes, right?
No, if you're looking for the big signals, they're easy to find, right? I don't need any of this fancy stuff. I just look at top.
But I think
These things are bad.
I think there is a catch, right?
Honestly,
Do you really care about an anomaly if it's small enough that doesn't really perform? So just let it be, okay,
Something has
somebody
changed.
made the package slightly less optimized.
I should take.
But one second, he said you look at top. What do you mean you look at
It's
top?
always we.
Top will give you some metrics that you can look at to figure out if there's an anomaly. They're doing it automatically. It's the same thing. You can choose what your metrics are. You can be processing, like, if I can look at top and say, okay, because of the CPU usage, now I'm hitting 100% for an hour. Okay, this is the metric I'm looking at to be able to tell if it's an anomaly. You want to do this automatically.
So, yeah, I mean, for instance, I think what Manuel alludes to is having a threshold, like anything that passes, but those threshold mechanisms don't work typically because it's difficult to set a threshold that's meaningful. I mean, you know this, you're in the anomaly detection other Prodigy project, but essentially thresholds don't work because of what you are saying. Like, you can't just say when top is above 85%, let me know. Because sometimes anomaly happens at a much different percentile. That's why automation makes sense.
Right, and it could be the case if you have a package that needs to compile and it's gonna use 100% of the CPU for a while, and that's not an anomaly, it's just the way installing that package works.
That's true, but then the system would just flag it as potential.
Yeah, I mean, basically, this is like having some automation to understand what's an anomaly, what is a divergent behavior compared to normal is still valuable, even if you can't pinpoint what caused it, right? And here you say, maybe you don't pinpoint it exactly, but you say more than just saying that there's an anomaly. You say that there's an anomaly and this package is correlated with this package installation, which is additional information. Sorry, there were some questions.
So my question was, several of your your metrics that you're looking at here are governed by more than just the packages that are installed inside your container. They're governed actually largely by the larger layout of the data center you're using, right? So if, for instance, my latency is spiked because somebody hosted my routing tables and I'm bouncing between two other different data centers before coming here, as opposed to coming directly, the system is going to see that and point at a package installation that has absolutely nothing to do with what's going on, right? So how are you accounting for the externalities that can mess with your metrics in the reports that you're actually giving?
Yeah, so again, the idea isn't to like give an exact like play-by-play of how the anomaly was.
No, but this is not just like we haven't given you a pointer. This is anti-info. I'm pointing you at package installs that have nothing to do with your spike in latency.
So there is a I think it's an edge case because at the time when your network tables messed up, you also happen to push a container change or some change that the system is pointing to.
Sure.
So if those align at the same time, then I assume that this will be the case.
So in very large scale companies, that's not an anomaly. That is
No, I mean,
normally.
the thing is, the code attack analysis doesn't just show the latest package installation. It shows what is correlated statistically with this anomaly. So if you happen to have a different problem that happened at the same time of the package installation, then sure, that package installation could be blamed incorrectly, but it's edge case because, you know, it would need to happen at the same time with a new package installation. Yeah, it's imperfect. Sometimes it could point to something that's not true. And that's why, you know, this is going to be reviewed by somebody.
Yeah, so the causal impacts, like at least like how the framework works, it's checking like the timestamp of, let's say, when you make a change to the anomalous metrics, and if that timestamp isn't as like close or like correlated to those anomalous metrics, it would have like a lower like impact value. So it would have to be like exactly at the same time. Let's say the latency occurs as you add a new package to have it correlate. Okay.
But I think when I think there was some Red Hat talk. I think last semester or before that, or 1 year before that, and all I was hearing from I think the observability team and the high-ranking Red Hat people were like, whenever anything breaks, we look for what changed. Give me what changed. I don't care about what all is going on, or mostly they look for what changed. And I think this approach helps them by giving them in a concise manner that, okay, this is what has changed. They can rule out that, okay, this doesn't make sense. We'll continue our debugging for the network thing because it looks like a network issue. But I think it would help as an operator that, okay, this is the concise that what has changed. Maybe it is helpful, maybe you can discard it.
Sure. No, I guess the question I'm having here is that the what changed, you don't need models for that. You know what changed. You have manifests of what's in your containers, right? So you see that. The observability, you see the metrics, right? And simple thresholding will point out anomalies, right? So I guess.
So that's not true, right? So we were just discussing that simple thresholding doesn't tell you what's anomalous.
Sure.
Because anomalies with respect to what was happening in the normal state. And in general, what changed, sure, you can keep track of what changed. But the idea here is to connect the anomaly detection with the most relevant change so that you don't have a ton of changes. So normally you have all this data, right? So nothing is new here. You have all this telemetry, you have all the packet changes. And you can say, I'm gonna just look at them all and figure out, but here, this is typically very time consuming and sometimes impossible. So the idea is to say that anomaly detected, this is your most likely cause. And there needs to be a study to show where, how much of this through, if this is still like bringing out 90% false positives in a real scenario, that doesn't make sense, right? So we don't have that study, but
That's why I was asking before, like, how can you know if this is working? But it's clear from the latest trials, the idea is to make anomalies that kind of look like something that might happen in real life and see if
Yeah.
the system.
In a way, this is much better than scourging through logs and figuring out what changed and when. This will kind of tell you, hey, this is where I think you should look at. But I agree that, no anomaly detection systems. I can see the reason why it was.
were you done with your slide?
Yeah, that was it.
Oh, okay.
I just had a question. Comments, slides.
This was done as a directed study. What was it? A result of a course?
It was a mix of Red Hat funding and our other funding. And Rohan and Jason are both undergraduates here.
Right.
So they worked initially on PraxiPaaS and last semester was on practice. So excellent work by undergrads.
Yeah.
And special thanks to Zongshan who name. Yeah. Who was the lead on the PraxiPaaS, the container package discovery.
Thanks for coming and presenting. This is very important. And don't feel intimidated.
And the real anomaly situation is a very big problem. So generally we always ask this, like if you are using NERC or another cloud system and you think your system experiences a problem, let us know. Like, this is the problem. It would be super valuable for us.